Hey guys, today we're going to take a look at this 12 volt 100 amp hour lithium iron phosphate battery from SOK. Now you may be looking at this battery and thinking, dude, you've reviewed these numerous times already. But this battery is different. This is their newer model. It's the H model, which means it has a built-in heater. This thing has a 60 watt heater built in, so it can be charged below freezing. They advertise it's good for down to negative 20 degrees Celsius, which is negative 4 degrees Fahrenheit. Additionally, this upgraded model comes with a built-in Bluetooth module, so you're able to connect to it from an app, view statistics on the battery, and things of that nature. So we'll do the usual process in this video. We'll do the capacity test, we'll tear it down. I'm fully expecting it to have the same cells as all the previous SOK batteries, but it should have a different BMS, it should have different internals to manage that heater and that Bluetooth. So here we go. Externally, this battery is pretty much identical to the original SOK. It's 12.8 volt nominal, 100 amp hours, 1280 watt hours. The max continuous charge current is 50 amps. The max continuous discharge current is 100 amps. And you can burst this up to 200 amps discharge for up to 3 seconds. Taking a look at the top, again, it's exactly the same as the original SOK battery. We have our rubber terminal covers for added safety. We have some nice long M8 bolts with a split lock washer and a flat washer to some screwed down terminal blocks on the top of this enclosure. And if we set it next to the original SOK battery there, we can see it is a little bit larger in terms of height. That's about 3/4 inch difference in terms of height. The overall depth is pretty much the same. And then it looks like it's probably about 1/3 of an inch longer in width. So all in all, pretty much identically the same as the original. Charging. Alright, so I've got my standard capacity test set up here, which is a Batrium shunt connected to a Watchmon 5 BMS, transmitting data to this display. We have voltage, amperage, wattage, discharged amp hours, and discharged watt hours. I'm using a 2000 watt inverter for my load connected to a series of incandescent light bulbs. Now I am going to use a slightly higher C rate on this battery. I am getting a later start on this test than I wanted, and we have already tested a number of the SOK batteries anyway, so it'll make for something a little bit different. So we've got about 34 amps on this battery, which puts us at a 0.34 C rate. So that should take about 3 hours to discharge. 106.89 amp hours. I expect nothing less from an SOK battery. That is excellent. One thing that's nice about these SOK batteries is they're always super easy to open and service if you need. You can see there's just a line of Phillips screws the whole way around the top of the enclosure there. Alright, with those screws removed, I can see the lid does not come off here, and as a matter of fact, I see there are metal strips, it looks like, are connecting the terminal post in there, so there is no flexible silicone wire like usual. So I'm going to have to very easily get a ratchet in here and try to remove those bolts. Alright, so I got safety glasses on just in case, and I've insulated my ratchet. This is a 10mm socket. Oh, that is tightened on there pretty good. That is a good sign that it's tight, but this one's the negative and this one's the positive, and you can see they just bolted to the bottom of these terminals here. Taking a look at our BMS on the top here, there's the model number. It is the SK4S120, and we can see the max charge current is 70 amps and the max discharge current is 120 amps. So we do have 20 amps of headroom both on the charge and the discharge side. Alright, we've got a number of connections on here. I can tell the 5-pin connector down here is going to be the balance lead. And this side is the B-, or the side that connects to the main negative of the battery pack. And from what I can tell, this piece here is just the other end of this bus bar. I think that attaches there. We have 2 leads down here, a 2-pin white lead and a 2-pin red lead. Not sure what they're for yet. We'll figure that out once we get the BMS removed. And then lastly, we have the temperature sensor connected here, which goes down. I don't know if you can see it. It's bolted all the way down there. Alright, so removal of that BMS did not go very well. It was in here like this. I tipped it down to try to wiggle it out, and I made contact here. You can see there's 2 burn marks. With the top of the bolts down here, you can see it's melted there a little bit and there a little bit, so it did make a fairly large spark, but But you know, that is why I do not recommend opening batteries, and that's also why when I do it, it's always at a 0% charge. We still have these two leads here. I need to remove this top bar to see what those are actually going to. I assume at least one of those is going to the heater. Alright, this is super cool. They actually have two heating pads here, wedged between the first and second cell and the third and the fourth cell. So I want to see if I can get this out further. I need to remove this bus bar, just so there are less exposed metal pieces. Alright, so I just pulled out the foam padding along the top here, and I found this white wire is going to a thermal switch down there, so that's pretty cool. And it looks like that switch is good for 50 degrees Celsius. Alright, so I think we can carefully slide this battery out. I want to put this down for some insulation there, just on the metal case. There we go. Let's see if we can separate one of these cells here. Alright, so there's the heater pad. There's not much to it. It's just a piece of sticky, I don't know, it's sticky on one side and rubbery on the other. I can kind of see the heating element coils running there. So there are two of these. Like I said, this must be a 30-watt panel. And then we can see the second 30-watt panels over here. So we'll go ahead and put this back together. Alright, so as we already know, these are 100 amp hour GFB cells. Same exact cells they use in their other batteries. They are clearly grade A. We did not see any swelling, bloating, or anything like that. Alright, so here's a look at the BMS board. There's a lot of conductive surface area here. It's quite impressive, the surface area, and there's even more on the bottom for those FET transistors. So at a quick glance, I see we have the Bluetooth module on the center left here. Additionally, we have a second temperature sensor that goes down right in the middle of where this heatsink would be. This thing looks a little odd here. I can't really tell what's going on. It's labeled D6, so I assume it's a diode, but that's an odd looking way to solder components. One more thing I wanted to add as I'm putting this back together is they went through some pretty good lengths designing this case. So they've got this top piece here. This bracket's got quite a bit of foam on the bottom, and it presses down, holds the cells in place, and has this nice wireway inside to route all the cabling through. That way there's no squeezed or pinched wires, and everything is firmly held into place. So, alright guys, so I've got my SOK battery here connected to a bench power supply, and this is the setup we're going to use to test the temperature control and the internal heater and how that works. But before we do that, I wanted to show you guys the SOK BMS app. So the app says SOK BMS at the top, but you'll actually want to search the Google Play Store for ABC-BMS. Okay, and we can see here it's at 0% state of charge, 12 volts. We can see cycle life says 0. I guess it won't start counting that until I charge it again, maybe. Current temperature is 17 Celsius. Charge and discharge MOSFETs are turned on. At the top here, there is also a detail tab. You can see it was manufactured October 21, at least the BMS itself was. Here we can see the voltages of all three cells. We can see they're actually fairly close together. Look at that. 3.01, so they're all within 0.02 maybe volts of each other. So while I'm doing this test, I'm going to keep an eye on this temperature down here. Alright, so I've got here a cup of ice water with some orange rock salt in. You can see on the power supply we are charging at 7 amps. I'm going to go ahead and dip this temperature sensor in the water. 10 degrees Celsius. 3, 2, 1. Alright. Look, it actually shut off and now it's at 4 amps. So we know that this power supply is powering the heater and trying to heat those batteries. The phone is reading 0 degrees Celsius, so it kicked on that heater pretty much as soon as it hit 0 degrees. So now we'll remove this sensor and I want to see at what temperature it starts charging normally again. So we're at 1, 2, 3, 4. Looks like right around 4 to 5 degrees Celsius is when it kicked back to normal charge. You can see we're sitting at 7 amps again. So that is very, very cool. So instead of this BMS shutting down the battery like you would see in a typical lithium iron phosphate battery, it simply kicks on the heater using power from the power supply. It disabled charging and it flipped on that heater and it did not resume charging until the internal temperature, read by this sensor which is affixed to the bracket holding the battery down, went to about 4 to 5 degrees Celsius. Very, very cool design. So there we have it, the SOK 100 amp hour lithium iron phosphate battery with a built-in heater. I really like the way this battery is designed. We have the same SOK quality as all of the previous batteries we have looked at. I like that those heating elements are in between the cell pairs like that. It's the entire footprint of the cell right in the middle. That way it's heating the battery from the inside, the core of the battery outward. And then we have the temperature sensor on the outmost surface, such that the heating element is not going to give the temperature sensor false readings. And that's compared to some of the other batteries we have seen in the market. I reviewed one a few months ago that had a coil wrapped around the outside of the battery, and one could argue that in those cases the heat is not penetrating to the center of the battery. So for those reasons, I do very much prefer this style of heated battery. One thing I've not mentioned yet is that this battery cannot be wired in series with other batteries. This is only for a 12-volt system. So if you did run into a scenario where you needed the heater in the batteries, it sounds like it would not function properly. I'm not sure what the specifics of that were. As for price, this sells for $630 both from SOK's website and from Current Connected. If you purchase from SOK's website, you get a 7-year warranty. If you purchase this from Current Connected, one of their authorized US distributors, you will get an additional 3 years on that warranty. So you will have a 10-year warranty on this battery. So yeah, that's about it. Questions or comments, you can leave them. Hit that like button before you go, and thank you very much for watching.